Okay, so this is where it starts for higher. Okay, every question is a past exam question. Read it, try it.
Uh, 20.
Yep. And how about say
15.
how many grey squares does it have? Correct. Fine. So that one's 20. That's 15. Okay, how about this?
Um, 6.
Yeah.
And then 10.
6 and 10. And so you can kind of see the pattern to the... that was 11. Hold on.
Oh.
So how many triangles are needed for pattern 6? So how many triangles are there for each? So there's 1. Oh, for pattern 6, not pattern 5. So that's 1, 3, 5, 7. How many would be pattern 5? How many 6?
Then 5 would be 9.
Mm-hmm.
And 6 would be 11.
That's it. And what often helps is if you make a table. So pattern number, pattern number and number of triangles. And if you do that, you can say 1, 2, 3, 4, 5, 6, and triangles 1, 3, 5, 7, and you can kind of see that it's going up in twos, starting one below, and that way you don't need the diagram. Okay. Okay, this one, start with B, complete the table.
13. And then 16.
Yeah. So they want you to find the number of lines in pattern 12. How would you do that?
Would you continue the T?
So that's going to take a while. I want to find is there any connection you can find between either the pattern number and the number of lines, or the number of lines themselves?
Times 3 and add 1.
Yeah, so it's like, okay, so times 3 and add 1, and so the 12?
So that'd be 39, no, 36 plus 1, 37.
Well done. So that is 37. Let's see, so that's times 3, add 1, so 12 times 3, add 1 is 37. Okay, so I just added in my own little extension questions here. Part D, what is the common difference between the number of lines in each pattern?
Plus 3.
Yeah. If there was a pattern number 0, how many lines would it have? And you can use the table or you can use the picture.
Or 1.
Yeah, 1. So going this way, it's minus 3, going down. Okay, so the equation of, do you know the general form of the equation of a straight line?
No.
So all straight lines, the equation of it can be written as y equals mx plus c. Yeah, so you've probably seen that before. For a sequence, they're going to ask you for the nth term, and the nth term is always the common difference plus term 0. And in this case, the common difference was 3, so it's 3n, and pattern 0 would be 1, and so 3n plus 1. And so if you did 3 times 12 plus 1, you get 37, and you can check your answer. Would 3 times 5 plus 1 give you 16?
Mm-hmm. Yeah.
Yeah, and so this is algebra. So it's not saying 3 times 12 plus 1, 3 times 5 plus 1, 3 times 4 plus 1. It's 3 times n plus 1. So just in general, that's it. And they just shorten it down to 3n. Yeah, so it's always common difference is the number in, that's like the m if it was the equation of a straight line, and c is the same thing. That's when x is 0, in this case when n is 0, term 0. To get the common difference, you kind of already know. You can do any term take away the previous one, and it's usually easiest to do second term take away first term. And then c is, I suppose, term 1 minus the common difference. So you're working in reverse. So let's try that. So that's just saying everything there. I gave it all away. Okay, so really tricky one. Let's try this.
Oh,
I'll come back to this one. I'll come back to this one. It's really tricky. No. Okay, so any idea how these work?
Would you do 1 times 2 plus 1?
Mm-hmm.
So then, so then that's just 3.
Mm-hmm.
And then 2 times 2 plus 1, which is 5.
Mm-hmm.
And then 2 times 3 plus 1, which is 7.
That's it. And you can see they're going up in 2s because the common difference is 2. And how about B?
So then 10 times 5. No, 10 times minus 5. Plus 20.
Mm-hmm.
So then minus 50 plus 20, so then minus 30.
Yeah. Minus 30. Okay, how about these?
So 2 times 3 squared minus 4, which is 18 minus 4,
Mm-hmm.
which is 14.
Yep.
And then 4 times 3 times 4 squared plus 5, which is 3 times 16 plus 5, which is 48
Mm-hmm.
plus 5, which is 53.
Well done. 53. Fine. Okay, so finding the term x a half tick.
Tick.
Yeah, so that's a substitution type. This, no, I should do, it's in the wrong place. How about this?
Um, uh, would you hmm, don't know.
So there's a very fancy way to do it. I think the simplest way is to just write down the first few numbers in each sequence.
Oh, okay. So then, 3 times 1 minus 2 is 1. And then 3 times 2 minus 2 is 4.
And what are they going up in?
And then 3 times 3 minus 2 is 7.
And what are they going up in each time?
3.
Yeah, and that's the common difference, 3. And so what will this first sequence be? If you continued it on?
Then 10,
Yeah.
13.
Okay, we'll stop there and we'll go further if we need to. And then how about the other one?
Then minus 2 times 1 plus 10 is 8.
Mm-hmm.
And then minus 2 times 2 plus 10 is 6.
And how much did it go down by?
2.
Yeah, and that's because it's minus 2 each time, so it's gone down by 2. So what will this sequence be?
8, 6, 4, 2.
Okay. And so what is this question?
It would be wrong. It's like, no. Oh wait, no, there is. Okay, yeah.
So yes, and why? Which number?
4.
Yeah, that's it. Any questions there?
Nope.
Okay, so no quick way to do that. Yeah, they did the same way. Okay, so you have to find the nth term for each of these. So try this. I'll just be 1 second, sorry. Why you need this man every single day? Sorry about that. What did you get for the first one?
Is it 5 n uh minus
Yeah.
or
So dn plus c. So for this one, common difference is 5. C is term 0, if there was one there before the first term.
5 n minus 2
Minus,
or minus 3.
yeah. And so nth term is? Oh, 5n minus 3, yeah.
Yeah.
That's it. Okay, second one.
4 n minus 2.
If it's going down in 4s to the left?
Oh, to 4n minus. Oh, oh,
6 take away 4?
minus 2 or no, plus 2.
Yeah. So C is always what term 0 would be if there was one. And
Okay.
this one.
Uh, 7n minus 4.
Well done. That was the hardest. 7n minus 4. Okay. Now we'll practice more. Okay, how do we do this?
So then the expression would be 6n plus 4. So then if we do 6 times 10 plus 4 is 64.
Well done. And so that is definitely the correct order. So I don't know why they put it as A and B. I think some students who don't know part B at least can find the long way of doing part A. But your way, I think, is the best way. Find the nth term first and then just sub it in. Okay, how about this one?
So then 3n minus 1. And then 3 so just 3 and plus 1 minus 1.
Yes. So it's basically, if it was the 10th term, like the previous one, we did 6, instead of 6n plus 4, it's 6 times 10 plus 4. So this would be 3 times, instead of 10 minus 1, it would be n plus 1 minus 1. So it's now algebra. So how would you simplify that?
3n plus 3 minus 1. So then 3n plus 2.
That's it. And they would have accepted the answer like that, just writing n plus 1 instead of n, so just subbing it in. Yeah, okay. Any idea about this?
So 3 times 2 minus 2 squared.
That would give you the second term. So they gave that to us. So this up here, the nth term of this sequence is 3n minus n squared. They're saying find the nth term for this sequence.
Oh.
Is there any connection? And it's not a linear sequence. Is there any connection you notice between the previous sequence and this sequence?
It's just double.
It's just double. And so what do you know about the nth term?
Would it be 6n minus n squared?
It's all doubled.
Oh, minus 2n squared.
Yeah. So it would be like doing 2 times 3n minus n squared. And so that's why it's the whole thing doubled. So it just came up 1 year. I just thought I'd better put it in just in case. Okay, let's try this. Oh, no. Now I can go back to the start. Just a little bit that I skipped. Okay. How about this? No. Even before that. Sorry, this one.
So we n.
So I don't think you're going to be able to do this without a table. So they've called these quadrilateral 1, 2, and 3. So I'm going to just do a table for that. So instead of pattern number, they've called it quadrilateral. And perimeter. So what is the perimeter of the first one, do you know? Or how do you find
it? You divide 24 by 3.
Yeah, what do you get?
8.
So each of these sides is 8. Okay, so that would be the perimeter of quadrilateral 1.
4 times 8, so 32.
So that's 32, okay.
And then 40. And then 48.
Okay, so try using the table.
So then 8 and plus 26.
And how'd you get 26?
Oh wait, no, 24.
Yeah, that's it. So this helps to write it as a table. 8 times 24. Any questions there?
Nope.
Okay, so that's a particularly difficult one. Yeah, it's 24 was a 3 marker. Most of yours were 2 markers. Okay, how about this?
So the nth term is
Simpler than that.
oh. Oh wait, it has to be multiple of 3.
Is it a multiple of 3?
Yes.
So does that mean it's in the sequence?
Yes.
6 is a multiple of 3, but 6 isn't in the sequence.
Oh. Is it odd numbers?
Yes.
Like,
and go on.
So then 150 divided by 3, which is 50.
Simpler than that. Every number in the sequence is odd.
So, and then 150 is even.
Yeah, therefore
Wouldn't be in the sequence.
that's it. Therefore Ben is wrong. Any questions there?
Nope.
So sometimes they're simple. Okay, how about this?
It never ends in 1.
Yeah, so 271 ends in 1, and go on.
And the other numbers don't. Ends in either 2 or 7.
That's it. Either 2 or 7. Therefore, the number 271, yeah, not in sequence. Not in the sequence. Okay, so those were the easy few. The next won't be so easy. Okay, let's try this.
For n minus 2. So then 4 times. Oh wait, no. 86 plus 2 divided by 4.
Well done.
So then
What's it give you?
So then it would be 88 divided by 4, which is 22.
And so, is it in the sequence?
Yes.
Yeah. It's term 22. So if we were to continue these numbers, it'd be the 22nd across. Okay. Okay, let's try these.
Okay. Then 6 and plus 5. And then 121 minus 5 is 116.
Okay.
And then divided by 6. So 90.
How many 6s in 11?
1,
Remainder?
5.
How many 6s in 56?
7, no, 9.
Okay. Remainder?
2.
And so it'll be 19 and 2. Or let's just say, if we were to bring the decimal, how many 6s in 20?
2, no, 3.
Yeah, and so it'll be 19.3 recurring, or 19 and a third. So is 121 a term in this arithmetic sequence? And why not?
Because you can't have the 19.3 recurring.
Yeah. N must be a whole number, an integer. And if you look at the sequence, if that's term 1, term 2, term 3, term 4, you can't have a term 1.5. It's not like there's a 15 in here invisible, or a 14. There's no term 1.5. I think, do you think it'd be okay for the one down the bottom, or you want to try it?
Can try it. So.
Okay, go for it.
So then 4n minus 2, and then 150 plus 2 is 152 divided by 4. Is not divisible. So it'd be...
Is your oh, there we go. Sounds just, I was getting feedback on my side. 152 divided by 4. How many? Yeah, go on.
Is it 19?
How many 4s in 15?
3.
The remainder.
3.
No. Oh yeah, sorry, 4. Yeah. And then how many 4s in 32?
And then 5.
No. It'd be 20.
Oh. Uh. 32.
Yep.
6.
No.
No, wait, no. Okay. Oh, 8.
Yeah. So is 150 a term in the sequence?
Yes.
Yeah. It's term 138, so it's a long way across. Any questions there?
No.
Okay, so yeah, the way you do these, and if you don't want to do it in your head, is so you write the nth term, and you know that that nth term has to be equal to whatever term they are saying is in the sequence. So 6 times something plus 5 gives you 121, 4 times something minus 2 gives you 150, and then just work backwards to solve it. If n is an integer, it's a number in the sequence. If n is not an integer, then it must not be in the sequence. So that one x1/2 tick.
Tick.
Okay, and that's where if it's a number in the sequence. Okay, so mixed test. Let's try this.
So 3 n plus 1.
Mm-hmm.
So then 3 times 20 plus 1.
Hold on. Will pattern 20 have 20 gray squares?
Oh. No. So just be 10. Yeah, 10.
Mm-hmm.
Oh, plus 1. So then 11 white squares.
Nope. Is there maybe? Let's see. So the pattern. Oh, so 20 gray, which means it will be pattern 10, and it's always one more, so 11. Yeah. 3n plus 1 and 11. Okay, how about this?
So 3 times 10 squared plus 7 is 307.
Well done. How about this?
5 n minus 1.
Mm-hmm. How about this?
Three n minus 1.
Mm-hmm.
299 plus 1 is 300, then divided by 3 is 100. and it's an integer, so it's
Why is that?
because it's an integer.
That's it. Okay, so sequences in general, x1/2 or tick.
Tick.
Yep. Okay, so we'll see if you already know how to do question 1.
Uh, 5.
Yes. And part B.
Y equals 3x minus 4.
Yeah. How about this one?
Y equals 2x plus 4.
Mm-hmm. This one?
Minus 3.
Yeah. Next?
Then 0, 5.
Yeah. You'll be fine there. You'll be fine there. This one, you have to find the equation of this line. Any idea how you do that?
Y equals 2x plus 5.
So it's going to be plus 5. And this time, it's not going up by 2, it's going down by 2.
Oh, y equals minus 2x plus 5.
Yeah. How would you do 6a?
2y equals 8 plus 10x. And then y equals 4 plus 5x.
So gradient?
5.
Yeah. Write down the equation of a line parallel to this. In any form.
It's 5x minus 3.
Yep. Let's just more of the same. Okay. So rearrange to make y the subject. I think you're okay. We'll try it.
2y equals 6 minus x. So then y equals 3 minus half x.
Well done. Gradient?
Half.
Mm-hmm. And C.
Y equals half x plus 7.
That's it. Equation of this line?
Y equals 2x plus 3.
Mm-hmm. And we can
Um, y equals half x. Oh, yeah, half x.
And so gradient?
Half.
Yeah. Okay, well done. So they wrote 0.5, a half is better. This, I think I'll come back to that another time. How would you draw this graph?
Would you do a table?
You could, yeah. What would you sub in?
Some x and y.
Okay, what would you sub in first?
X. But 1, 2, and 3.
Yeah.
Oh no.
Yeah. Yeah. And what type of graph is this? Y equals 2x minus 3.
A straight line graph.
Yeah, straight line graph. And so for a straight line graph, you only need 2 points if you recognize it's a straight line graph. Which 2 points will we pick?
Minus 2 and 2.
Okay, go for it.
So minus 2x minus 3.
So x is minus 2 for the first one.
Oh, 2 times minus 2 minus 3. So then minus 4. No, 4. Or is it? Oh, okay. Minus 3. So then minus 7.
Yeah. And so what coordinate is on the graph?
Minus 7, 0.
When x was minus 2, we got minus 7.
Oh, minus 2, minus 7.
Well done. Okay. And what's next?
Then y equals 2 times 2 minus 3. So then 4 minus 3 and 1.
Okay.
So 2, 1.
Well done.
And then put them on the graph.
So how do I put the first one on?
Along minus 2 and then up and down to minus 7.
Yeah. So minus 2 on the x, minus 7 on the y. That's there. And then 2 on the x, 1 on the y. That's there. And finally?
Then draw a line to the other point.
Yeah. That's it. Any questions there?
Nope.
Yeah, so this is a bit like the subbing in the first few terms of a sequence. Like you could sub in 1, 2, 3. If you notice that it's a straight line, you can just get the first and last and join them up. But the other method will work as well. And in fact, the other method will always work for quadratics, cubics. It equals 1, it equals 2, it equals 3. Sub them in for x and find the value for y. So how about this one?
So y equals 2 times minus 3 plus 3, which is minus 6 plus 3, which is minus 3. Minus 3 minus 3. Then y equals 2 times 1 plus 3, which is 2 plus 3, which is 5. So then it's 1 5.
It's what, sorry?
1 5.
Yeah. And then
On the graph it's minus 3 minus 3,
mm-hmm.
and then 1 up 5.
And finally,
Join the points.
yeah. Any questions there?
Nope.
Okay, let's do a quick recap. So we didn't get equation of a straight line is huge. Anyway. Sequences. Maybe I'll just go from the. I'll see. Yeah, so these ones you can just kind of figure out from the pattern. If you need to, you can always create a table. So you could create a table for pattern number and number of white squares, something like that. This one you can, yeah, we created a table down the bottom, and so that was for triangles. For stars you can always create a table as well. If it's going up in ones each time, so it'd be like 1n plus 1 or just n plus 1. How do you find the nth term for a sequence?
The difference plus the term 0.
Yeah, the constant term 0. And yeah, dn plus c. So this was just tricky. So here, you know, you do it in your head in the end. Yeah, so quite not very common a higher, but sometimes this is odd, and so that's easy or even, and they're all odd. What if it wasn't? What if this was an odd number? How would you go about solving this one or figuring it out?
Just would you do the nth term and then sub it into that?
So nth term and then equate it to that, yeah, and
Yeah.
then try to solve it, yeah. So this one again, another easy one. The 271 ends in a 1. Every number in the sequence ends in a 2 or 7. Because it's the 5 times table, it's 5n minus 3. So the first 3 terms, why did these go up in 2s, 3, 5, 7?
Because it's 2n.
Yeah, because and 2 is the common difference. Expression for this, the 10th term, just sub in 10. So these with quadratics you were fine, just BIDMAS. These ones, the easiest way is just write out sequences by subbing in the first 5 terms in each case. Yeah, so common, how did you get 5n minus 3?
Because the difference is 5, and then 2 minus 5 is minus 3.
That's it. So that's those. And then equation of a straight line. Good. And how would you find the equation? How would you draw the a straight line from an equation?
Work out the x and y values and then put them into coordinates.
Yeah, and then join them up, I suppose. Yeah. So that's sequences and then the beginning of equation of a line. How was that for you, Hannah?
It was good. Useful.
So if you like, we can continue equation of a line next and then move on to maybe quadratic sequences, just because equation of a line, there's quite a lot to it. How does that sound, or you want to do something else?
Yeah, it sounds good.
Okay. Any questions for me in general?
Nope.
Okay. Well done, Hannah. You're doing great. I look forward to talking again next week.
Yep.
Have
Bye.
a good week. Goodbye.